There are moments in science when everything we thought we understood suddenly becomes uncertain. When long-standing theories begin to crack under the weight of new evidence. And when the universe reveals something so unexpected that it forces us to rethink reality itself. That is exactly what is happening today with the James Webb Space Telescope. Built to explore the earliest chapters of cosmic history, Webb was designed to look deeper into space, and further back in time, than any instrument ever created. By capturing infrared light that has traveled for billions of years, it allows us to see the universe not as it is today, but as it once was. In many ways, it is not just a telescope. It is a time machine. And what it is showing us is far more complex and surprising than anyone anticipated. One of the most astonishing recent findings involves a supermassive black hole moving at extreme velocity through intergalactic space. Black holes are usually imagined as stationary giants anchored at the centers of galaxies, quietly consuming matter over time. But this one appears to be different. Instead of remaining fixed, it is traveling through space at millions of miles per hour, cutting across vast regions of cosmic material. Even more unusual is what appears to be happening in its wake. As it moves, it interacts with enormous clouds of gas and dust. Rather than simply destroying everything it encounters, the black hole seems to be compressing these materials in specific regions. Under the right conditions, this compression triggers the formation of new stars. What emerges is an unexpected structure, a long, luminous trail stretching across hundreds of thousands of light years, filled with newborn stars. For decades, black holes were viewed almost exclusively as destructive forces. Cosmic devourers. Endpoints of matter. Regions from which nothing could escape. But this discovery suggests a more complicated role. In certain environments, black holes may also contribute to creation, shaping new stellar systems as they move through space. A force of destruction and formation at the same time. This idea alone challenges established assumptions in astrophysics. But Webb's discoveries do not stop there. Another major breakthrough involves the detailed observation of a distant cosmic collision known as ARP 220. This system represents the aftermath of two galaxies that began merging hundreds of millions of years ago. When galaxies collide, they do not crash like solid objects. Instead, they pass through one another over vast timescales, while gravity reshapes their structure. The result is a chaotic, slowly evolving transformation. Webb's infrared vision has revealed this process in extraordinary clarity. What once appeared as a faint, indistinct glow now resolves into a complex structure filled with dense dust lanes, active star-forming regions, and two distinct galactic cores still locked in a gravitational dance. Each core contains its own rotating structure of gas and stars, gradually spiraling toward a final merger. Between them lies an intense region of activity where gas clouds are being compressed to extreme densities. In these regions, stars are forming at a rate far greater than in typical galaxies. Massive stellar clusters are born almost simultaneously, lighting up the surrounding material in deep infrared hues. The entire system resembles a cosmic storm, slow-moving but incredibly powerful. Extending outward from the collision are long tidal streams of matter, pulled and stretched by gravitational forces over millions of years. These structures act as a record of the merger's history, preserving evidence of every stage of the interaction. By studying systems like ARP 220, scientists gain insight into how galaxies evolve over time, including how our own Milky Way may have formed through similar processes in the distant past. But perhaps the most profound revelations from the James Webb Space Telescope come from even farther away. At the edge of the observable universe, Webb has detected extremely distant galaxies whose light began its journey toward us more than 13 billion years ago. In other words, we are seeing these galaxies as they existed shortly after the birth of the universe. What scientists have found is both exciting and puzzling. Many of these early galaxies appear more developed than expected. They are brighter, more structured, and in some cases more massive than current cosmological models predict for such an early time period. According to existing theories, galaxies should have taken longer to form, gradually building up mass over billions of years. But Webb's observations suggest that this process may have happened faster and more efficiently than previously believed. This has sparked intense discussion among researchers worldwide. Some scientists believe the current models of galaxy formation may need refinement. Others suggest that unknown physical processes in the early universe may have accelerated star and galaxy formation in ways we do not yet fully understand. There is also the possibility that our interpretation of some of these signals could be incomplete, requiring further observation and confirmation. Whatever the explanation, one thing is clear: the early universe is far more complex than we imagined. And Webb is only beginning to reveal its structure. What makes this telescope so powerful is not just its ability to see far away, but its ability to uncover patterns hidden in infrared light that can pass through cosmic dust that would otherwise block our view. This allows astronomers to study regions of space that were previously invisible, including stellar nurseries where stars are actively being born, and ancient systems shaped by violent cosmic events. Each new observation adds another layer to our understanding, but also introduces new questions. Why do some galaxies appear to mature so quickly? How do black holes influence their surroundings in ways we never expected? And what other hidden structures exist in the vast expanse of space waiting to be discovered? Science progresses through this balance of discovery and uncertainty. Every answer leads to a new question. Every breakthrough reveals a deeper mystery. The James Webb Space Telescope represents one of the most advanced tools ever created by humanity to explore these questions. And yet, even with its incredible capabilities, it has only begun to scratch the surface of the universe's complexity. As data continues to pour in, astronomers remain alert for the unexpected, for signals, structures, and patterns that do not fit existing theories. Because history has shown us something important. The universe rarely behaves according to our expectations. From runaway black holes reshaping galaxies, to cosmic collisions forging new stars, to ancient galaxies challenging timelines of creation, Webb is revealing a cosmos that is active, dynamic, and constantly evolving. And perhaps the most exciting truth of all is this: we are witnessing only the beginning of a new era of discovery. Out there, beyond the reach of current imagination, the universe is still writing its story. And James Webb is simply the first instrument capable of reading it clearly.